Hey, hey! Welcome, everybody! Welcome, Orlando Houdini users! Welcome to another episode of Houdini Live. Houdini Secrets Live, mind you. Now, I don't really know if we're bestowing so much Houdini secrets, just a whole bunch of Houdini experience. And honestly, there's a lot of good Houdini users over there, and they all have something good to offer. So if you ever see a Houdini user, go ahead and ask them, hey, how does this such and such work? And they'll probably bend over backwards to help you and help you figure out whatever problem you had. So, okay, big developments. Okay, this week I was able to go onto GitHub and I put on, I'm going to put this screen on here, and hopefully you can see that. If you can't see that, or if things are bad, go ahead and try to say something in the chat, or if anything is going on. But we should have at GitHub, if you go to TechArt.edu, the OHUG Foliage page. And I've got this procedural foliage demo going, and it is on here, and it is available for downloading. And so what we have here is the procedural foliage demo that we created a couple of weeks ago. We have last week's less than favorable conditions, and we're going to have this week's as soon as it finishes. Now this is an ongoing project, and we're going to keep on working on this, but we've got lots of stuff, and if there's anything that you guys want to see, or anything that you guys need to see, or any questions, please feel free to contact me any old time. Send information to the Orlando Houdini users group. Send it to the group, and hopefully somebody will field your question as quickly as possible. Oh, this is also very important for those people inside of for those people out in Houdini land that are students, and you plan to submit something for the Houdini student submission, please get back to me. Either Crota at ucf.edu, Chris at techartedu.com, or send me some information on the Orlando Houdini Users Group webpage. Send me if you're going to submit something. I need to start putting stuff together. I need to start telling the folks over in Side Effects on what to expect. They are anxiously awaiting for our work. Okay, cool. Get that into me. Let me know as quickly as I can, because otherwise, well, hopefully we don't have to let this thing go. But if you have anything work, I would love to get your work. Don't think that your work is too sucky or not good enough. I believe you. It is good enough, and if you even want to do something like animation is awesome. So get your stuff in and bring it in, because it's all really, really, really good stuff. All right. With that said, let's get moving along to where we were from last week, and I am going to shift this over onto my Houdini display. Okay. Let's see. Look at this going here. Okay. All right. Oh, that's terrible. Okay. But that should look a whole lot better. Okay, very good. All right. Now, last week we left things off in kind of a sorry state. What we had here was multiple trunks coming off of our tree. And if we come up here, if we go over to our tree gen, it should have looked like this. I've got multiple trunks. And so if I go ahead and I crank on this value here too, we see we have multiple trunks coming right here, which is what we want. Or if we just leave it at 1, that's really what we want. However, what was happening was, and this actually I don't think I copied onto the GitHub site. What happened was, here, check this out. I'm going to shake this sucker like a mad dog. And it came off. All right, so if you put this node in between here, that's not what happened, and going in here, this is what was happening on there. And if we put this fetch metadata, fetch feedback, okay, this is what we were getting last week. and which is garbage, and it wasn't working, and so we started to end up with lots of wacky, nutty results like this, and it was not good. It was not good. I don't like it. And so that's not good. So the problem was this copy to branch was copying over itself a bunch of times, and it was creating a recursive infinite loop, and which didn't get us anywhere. So let's shake this sucker like a mad dog again. Okay, we got rid of that. Put this back into here. Put this guy out of the loop, and we should have a branch to template coming right out. And make sure that the trunks begin is metadata, fetch metadata, and this trunks count is also metadata. All right, I'm going to put this number of trunks back over onto 1 right now, just because we are going to start branching off our tree to behave in recursive nature. All right. So as you can see, that's all we're going to do. So how are we going to clean things up? Well, what I'm going to do is I'm going to move this stuff over here, and I'm going to put a group right around all this for loop, and then I'm going to come over here, and then I'm going to create a network box around that. And then I'm going to call this network box trunks loop. Trunks loop. All right, cool. Now, with this trunks loop here, I could just move this group around as an entire unit, and I could even color it something else. So with this selected, I'm going to hit the C key, and my little color palette's going to come off. Let's color this kind of like a green color. Yeah, that's good enough. And I'm going to hit C to get rid of that. Okay, there we go. We are good to go. And I'm going to save this file off as, with the date, 6/12 HIP, and the contents from this lecture will be posted on the GitHub website after class today. So take a look for that. If you get lost behind, you can check out the Houdini file from the website, from the GitHub, and it should have it all for you. Plus the video should be posted as well. And I think I forgot to post last week's video. Apologies. Okay. Alright, so what we're going to do is we're going to prep for the branches. And in order to prep for the branches, we need to add a whole bunch of new properties to our digital asset. Now, this, what we should have done was create a nice formal list of all of our parameters going into our digital asset and then arrange everything nicely. We're doing this kind of in a haphazard way. It's good enough to go, but technically we should do this in a little bit more organized patterns. But all right, let's see this. If we go over here, go to type properties, where we have the type properties for our HDA, and what we're going to do is we're going to fill in the branches. So the first thing we're going to do is we're going to get a branch seed. So I'm going to grab a float, put this over under branches, and call this guy branch, capital seed, and then my label I'm going to call it branch space seed. Alright, that says seed, kind of like he's from Slytherin. Okay, and for a default value, I'm going to give it a default value of 84.84. Okay, very good. Hey, thank you. Yes, I know I'm on Houdini Live. Alright, so that will hold our seed value just for our branches, because we're going to have a special seed just for our branches. Now we're going to have like the number of children, which means, in other words, the number of branches. So we should have a number of branches that we want to work with for every single level. So let's go over here with this integer, grab an integer and put this under branches, and we'll go number children, and for the label we'll call this number children slash level. Okay, bumper. Number. Okay, the number of children per level. Okay, I'm not going to go crazy. I'm just going to leave this at 20 right now, as a default value. All right, now we've got that, and so now we're going to have a place to show where the start range is where we want their children to appear along our branches. And so with that, I'm going to need a float vector 2. And a float vector 2 is just 2 vectors. So I'm going to put that under branch. And I'm going to call this child range. And child space range. Okay, cool. Now for the channels here, what we want to do is give it a start point. So that means that for every branch, I want only the branches to, I want the child branches to start at maybe 20%, so that's 0.2. And I want the branches to finish, all my sub-branches to finish by 90%. So I want all my branches to happen between 20% and 90%. All right. And so we got the branches, the number of children, we got the child range. All right, so something we also need to include here are the number of branch levels. And actually that's kind of an important one because that tells us how many recursive layers of branches we're going to keep. Now, a couple weeks ago we worked on the very simplistic tree generator, and that had 3 layers of branches. It had our trunk, it had our boughs, and it had our branches. So that was 3. We can have much more than that. We can have an indefinite amount, and so we're going to have to tell it how many levels we actually want. So we're going to use an integer value here, and I'm going to pop that right into here, branches. So I'm going to declare the name as branch levels. And make that name label branch levels. Okay. And so here we want the default value to be 1. Now the reason why I have default value is because we at least want trunks. And trunks will give us a value of 1. So we at least want that. If we want more, then we'll get 2. And I'm going to change the priority. So we have the branch seed, so the number of branch levels we have is actually kind of important. So I'm going to drag branch levels here in the menu. I'm going to drag that off and drop that off under branch seed. So it's right there. So it's actually kind of important. It's right up there. All right. So we have the child and range, and then so forth. I want to know the number of clumps. Now the clumps is actually, because I grabbed this algorithm from Jerry, thank you very much, Jerry. Jerry worked with the concept of clumps, and that means he clumped his branches all the way up here. So we have to establish how many clumps that we want. And so let's grab an integer and put this under branch here. And I'm going to call this clumps. And for the label, I'm going to put number clumps / per level. Okay, so that's going to give us the number of clumps that we have per level. So let's have, let's say that we have 5 clumps. And let's just go with that and see what happens. Okay, so here's where we added the branch seeds, the branch levels, the number of children, the child range, and the number of clumps. Let's put number of clumps before child range, because that might end up being more important at the end of the day. So I'm going to go ahead and hit apply. So there's our interface. It got created. I'm going to click accept just to put it away and leave it for now. We're going to come back to it in the future. We got a lot more parameters to add in, but we're going to come back to that for now. So let's drop back into our tree gen. Okay, guess what? If this is the first time that you used a loop, well, start getting into the habit of it. They're a little bit tricky, and they take some getting used to, and we're going to provide that opportunity right now for you, because we're going to create a brand new loop. So right-click down here and add a new for loop for each number. Okay, we've got a new for loop, and so change the name of the nodes to spine. Instead of for each, change all the prefixes for spine. So this one is spine underscore begin. This is spine underscore count. And this is spine underscore end. Okay, so for this gathering method, we are going to merge after each iteration. We're going to merge everything back together. Our spine begin. We're going to make sure that that is fetch metadata. Oh, fetch feedback. I think that's right. If it's not, but feedback is right because we want it to keep building on top of each other. And for the spent spine count. Okay, we've got our spine count here. We're going to make sure that this is fetch metadata, and we're going to put the display on there. Okay, gather equals 10, feedback 9. Oh, for the number of iterations, let's see, we want the number of branch levels. So we want to go through this entire loop, the number of branch levels times. So ch, and then in parentheses, we're going to go double quotes, and inside of double quotes, we're going to go dot dot slash branch levels. All right, and it clicks. Okay, so it's 1. So we should have a value of 1 here. Now we don't have anything in there yet. We don't have anything in there quite yet, but that's okay. We're going to solve that in the near future. Oh yeah, and we want our loops to start at 0. Start value at 0. So this is why what we put in a value of 1 in the minimum number of branches. We started at 1. So that means that we're going to end up with at least one version, and that is going to be our trunks. Okay. Now, actually, I got this little technique from Jerry when I was reverse engineering his code, and this is a pretty cool technique. He didn't like accessing the data from spine count here. Now, spine count here keeps track of its data as a detail information. So if you go over here to inspectors, go to geometry, if you go over here to detail, notice that here's our information. Excuse me. Here is a value for iteration, and now here is the integer value, so it's an I value, and the number of iterations we're going to go through is 1. And so value, this is the floating point value. So here's our iteration number. Here we have our integer value, or float value, and then the number of integers. All right, now accessing this data from the detail is kind of awkward. And so what Jerry did was he actually threw in a null node down here. And this is pretty cool. And we got a null node. And so we're going to call this null node spine info. Okay, so let's do a little treatment on that. We don't need to necessarily do anything with it. It's just going to hold us some temporary information. So I'm going to make sure it's selected. I'm going to go ahead and put up the color browser. So I hit C, then my color palette is. I'm going to color it yellow, meaning that kind of like, pay attention, here's some information. And I'm going to change its shape. So I'm going to press Z to bring up the shape palette. And I'm going to give it a little explosion here, like, hey, look at me. This is kind of like groovy stuff. And I press Z to get rid of that palette again. All right, we've got this shape info, but you see it's just a null. It doesn't do anything. Aha! That's because we can go and do some nutty stuff with it. So what we're going to do is we are going to give it some information. And that information is, I want to expose what this iteration number is, and I want to expose it to this on the channel level. So I'm going to right click on this bad boy, and then where it says parameters and channels, I'm going to come over here where it says Edit Parameter Interface. And look at this. This brings up like a HDA node, but this is an HDA edit node, but this is just a parameter window just for this node. So that means we can customize any node we want to have any kind of spare channels that we want. And this is what we're doing. We're creating a spare channel on here. And so what we're going to do is I'm going to drop let's see, what do I want here? Drag an integer. Okay, I'm going to drag an integer down here. I'm going to put this under root. Okay, and I'm going to call this just simply iteration. And call this iteration. All right, and then I'm just going to hit accept. Okay, no harm, no foul. Now look at that. It created a little function, or it created a little interface for it in the null holder. And now this doesn't hold anything. So what I'm going to do is I'm just going to type in the information to get our iteration info. So I'm going to say detail, open parentheses and close parentheses. Now inside my parentheses, I'm going to put 0, comma, in quotes, I'm going to put the word iteration. And then I'm going to cap that off with 0.0. Or just 0. Okay, now if we click on the value, it gives a value of 0, which is totally fine. Okay, what this function does is this detail. So remember what I said that this information is stored on this null in the detail information? So what we're saying is, okay, grab this detail information and grab it from my 0th input. Well, there's only one input, so it's default by input 0. And then grab the iteration parameter, and if that doesn't exist, give it a default value of 0. And that's what this means. And so now we have this easy to convene and easy to grab channel that's now exposed to us at all ends. And we're going to take advantage of that in the near future. Okay, so that's a really cool thing. So what we're going to do is we are going to suppose that we've gone through and we've created a trunk. Now we haven't created a trunk yet, but just suppose we have. In fact, should we do this? Should we not? Yeah, let's go ahead and do this. Alright, I'm doing a little bit out of my notes, and that means I'm playing with fire, but sometimes you gotta live dangerously. Alright, and I made this for each loop nice and big so it stores lots of information. I'm going to put my trunks loop and put this right in the middle of here, and I'm going to use my spine info here to make this big and give us a lot more room here. Okay, now what I'm going to do is where it says copy branches to points, I'm going to put this information right into there to the spine end, and look at that. We have one bit of data. Okay, so what we're going to do is we're going to say, oh, okay, and then we're just going to leave that information in there. Oh, it disappeared. Oh, but there it is. Okay, what I'm going to do here is suppose that we have this loop, and this loop is going to come through there. I know we haven't hooked it up yet, but hang with me. You're going to see what we're going to do here. So what I'm going to do is I'm going to say, okay, I want to scatter a random number of points along this edge here. Because right now we just have 2 points, the beginning and top. Suppose we just want a random number. Okay, I'm going to put a scatter node down here. So I'm going to go grab this and say scatter. And I'm going to leave this here, but with a forced total count, I want to say the number of children I want. So ch, open and close parentheses, oops, there's a times, open and close parentheses. Inside that, I'm going to open and close double quotes, and then say / number children. Okay. Alright, so we've got that going here. So I know we don't see anything yet, but hang with me and you'll see what we're getting at. Alright, so we want this trunk to go through on the first iteration, right? But on all future iterations, we want to send the results through this pipeline here and then start recursively going on this pipeline instead. So we want to do this part first, and then after the first one, we want to do it on this side. How are we going to do that? Well, what we're going to do is we're going to create a switch node that tells this for loop of whether we're working on the first one or the trunk, or if we're working on the branches. So I'm going to grab a switch node. Now put that right here. So I'm going to put the trunks end here, and I'm going to put that right into there for the copy to branches. Okay. And so what I'm going to do is I'm going to put a little expression here that gives us a condition that's going to test if our information is going to come from our trunks loop or if it's going to come from our branches loop. So I'm going to go ahead and then type in an expression here that takes advantage of our spine information. So I'm going to say if ch open and close parentheses, insert open and close double quotes, and then spine info slash iteration. Okay, if this value does not equal 0, so that means it's going to evaluate this, and if it equals 0, it's going to take this trunk. If it's not, I'm going to hit enter, and right now it should say 0. Yes, it does, and so it's coming in through there. But if this somehow goes to beyond 0, then I want it to come from here. So I want it to come from this point. So now you can see this switch is now choosing which branch to go from, either this direction or this direction. And right now, because the number of iterations is set to 1, that means it only comes through here. See, there's a method to our madness. Now, let's go ahead and see if we move the iteration to 2 to see what happens. I'm going to go up a level, and so with the branch levels, I'm going to change my branch level from 1. I'm going to change that over to 2. And okay, spine info, the number of iterations. Okay, so we go through here, go here, we'll go here. Okay, iterations 2, the start values. Okay, sometimes I find that you got to kick this in order to get it going here. Okay, spine iteration. Oh, iteration. Okay. Okay. Okay, when in doubt, this is what you do. Come over here where it says it says iteration now equals 1, so it should equal 1, but it doesn't equal 1 here. So what we got to do here is, I'm going to go ahead and click this. I'm going to right click the word iteration, and I say copy parameter. Okay, now I'm going to go over here to the switch, and I'm going to just select everything, delete it, and then I'm going to right click and then say paste a relative reference. Okay, ch spine info iteration, and hit enter, and whoa, look at that, everything changed. So now what it's doing is it's not grabbing from this anymore, it's actually going from there. But I wanted to say that I want it does not equal 0. Okay, so nothing should change. Okay, so this is cool. Look at that. What this did was this copied a branch for every one of our new scatter points that we created over here. If we put the node around here, look at that. If we go along here, our spine goes right here. Here's our straight edge, and this has just 2 points. But what this scatter does is it inserts a whole bunch of points in between there. And then it says, okay, use this branch or this direction instead of this one, and then copy this branch template, this one, to every single one of these points. And voila, there we go. Okay, now I know this isn't looking like a tree yet, but you know, Rome wasn't built in a day, and this is actually really good. We're in a good place, and so let's continue moving forward and keep on adding things. So, okay, so what we have to do is notice that all these branches, they're all pointed in the same direction. We have to put some kind of rotation information in here. And let's go ahead and then add that to our type properties. So I'm going to go up a level, and I'll right click here, go to type properties. Okay, so we have our branches and we have all our child information here. Let's keep things a little bit nice and orderly, and because this is kind of like information about the recursive nature of here. So what we want to do is deal with just the rotations. So I'm going to grab a separator over here and put that in branches. So we have a separator going into there. And so let's go and grab 2 3 vectors. I'd say 3 vectors. Yeah, it's a vector with 3 values, x, y, and z. So what we want to do is establish the minimum and the maximum amount of rotation that we can do. Okay, so I'm going to grab float vector 3, and I'm going to drop that in branches, and I'm going to call this one branch rot min. Branch rot min, and let's call this minimum branch rot is minimum branch rot. Okay, so let's put some default values in there. So we want this to be -1 in the x, minus 0.3 in the y, and -1 in the z. Oops. All right, now let's go and grab another float 3. Actually, what we're going to do is just duplicate this one. So I'm going to select that one, hit Control C, Control V, and then we have a duplicate. Now let's change this one around. Instead of branch rot min, let's call this one branch rot max, because this is the maximum amount of rotation that we're going to do. And so we're going to call this maximum. You guys ever see that movie Gladiator? And they call it Maximus? Like, that's cool. Like what a name. What a thing to call your kid, Maximus. I don't know what the female version is. I guess it would be the same, but Maximus could be male or female. But what an awesome name. That's setting your kid up for success. Okay, look at that. This is still -1. All right, I have to change that. All right, so we've got the maximum branch value. Okay, this one needs to be 1. This needs to be 0, and this needs to be 1. Okay. Okay, there we go. Apply, and there we go. There we have a nice little separator to separate these things so we can noodle with them individually. I'm going to click Accept. Okay, now we have a way of rotating our branches. Okay, so off of this scatter here, what we're going to do is we're going to give each of these nodes a normal. And with that normal, we're going to add some random rotation. So we're going to do that using an attribute randomize SOP. So I'm going to grab this with attribute randomize. Okay, I'm going to drop that right in here. All right, and so I don't want to add color. I want to add my normal value. Aha, so look at that. It offsetted and made things nutty looking already. So that's a good thing. But let's put things in a little bit, okay, first, before we do anything, let's go and give us, because this is a random function, and this is going to use some random values, let's go ahead and set a new global seed for this. And let's say that the seed has to change for every iteration. Okay, so I'm going to go over here where it says options, go into a global seed. I'm going to highlight this. I'm going to hit Alt-E to kind of make this a little bigger so you can see it. All right, we're going to type in CH, open and close parentheses, open and close double quotes, and go ... slash, okay, spine info, that's what we want, and we want the iteration number. Okay, we got that value, and then what we're going to do is add that to our branch seed and our master seed. Okay, so plus CH, open and close parentheses, open and close double quotes, and inside of there I put ... slash master seed, there it is, and plus CH, open and close parentheses, open and close double quotes. Inside of that, I would .. slash branch seed. There it is, right at the bottom. All right. Oops. I'm going to click Apply. No errors, and this thing changed up a bit. Okay, well that's good. Groovy. Okay, click Accept. And now I see our global seed changes now for every single iteration. And that's good. So let's pop back in here. Let's set our minimum values and our maximum values. All right, so we're going to do things a little bit differently here. So once again, I am going to tip my hat to Jerry, who is the one who came up with this expression. And it's a good expression, and I like it. I'm going to use it from now on. It's because it's pretty cool. So let's take a look at this. I'm going to hit Alt-E to open this up. So this expression is, we're going to get the branch rotation minimum value that we are to use it for, but then we're going to fit it within a specific range so that it's always going to look good. So ch, open and close parentheses, open and close double quotes, okay, // branch rot min x. There it is. That's what we want. Yes, sir. And then what we're going to do is add this. Go add fit 0, 1. All right, fit 0, 1. That doesn't mean that this operation has been, went to the gym this morning and worked out and became Arnold Schwarzenegger. No, what this means is it's going to take some kind of value and it's going to fit it in between a minimum value and a maximum value. But the only condition is that this value as input has to be somewhere between 0 and 1. And what better what better number to that is a output from a random function. So I'm going to go rand, fit, open and close quotes, or parentheses, and inside of here we'll go rand, and I'm going to go branch seed, open and close double quotes, and what we're going to do is put double quotes in there, parentheses, and go // branch seed, branch seed. Oh, there we are. Okay, now what I'm going to do is I'm also going to add the iteration to it, because I don't want this to change on every iteration, and I don't want any kind of repetition happening. So I'm going to add plus, and then ch, open and close parentheses, insert in that open and close double quotes. We're going to go // spine info, and then iteration. Okay, so this is what it looks like altogether. Let me go ahead and expand this so you guys can see it. Oh, we're not done yet, because we just finished adding our input to our branch seed. But let's see. Oh, wait a second. This one is missing a ch. Okay, rand ch. Okay, rand. This should be ch. Open and close parentheses. Put that in there. I thought something was nutty. Okay, well that means that this is going to get inputted into there. That we're going to go and copy this stuff here. Hit Control X, and then insert it right into there. All right. All right, very good. And now, let me make sure that this is okay. So I'm going to put this here and I'll just test this. Okay, if this parameter is it. Okay, so that's right. So what we have to do is we have to fit it a minimum and a maximum value for our rotation. So just be happy that Jerry and I went through this and we like these values. So what we're going to do is put a value of -0.2 for the minimum value, and then 0.2 for the maximum value. Okay, let's just apply. Uh-oh, unable to... Ugh. That's not fun. Okay, so we did this wrong. So where did we do this wrong? So let's start with the the random statement. And I'm just going to go ahead and delete that. I'm missing a comma. All right. Let's see if this builds here. Apply. Yes. Ooh, look at that. Sexy. It's looking better and better. Okay, that's very cool. So I'm going to click accept. And so we have a nice, beautiful, fancy expression in here for the minimum rotation for our x direction. Click accept. But we're going to want this value propagated to y and z. So what I'm going to do is I'm going to put my cursor inside of this first channel, hit Control A, then Control C to copy it, and then I'm just going to hit the Tab key. That's going to go on to the next one, hit Control V, and that's going to paste the exact same formula, but I'm going to move you over here where it says branch rot min x. I'm going to change that to y, branch min y, hit enter, and then I'm going to drop over into this next parameter, hit Control V to paste it again, and then move on over to where it says branch rotmin X. I'm going to change that to branch rotmin Z. Okay, ooh, look at that. Okay, so we're getting some wacky values all over the place, but this is good. We've got minimum values and we've got maximum values. All right, suppose we were in a hurry. Well, now we're not in a hurry, so let's take it easy. So where it says max value, I'm going to go ahead and click the max value, and I'm going to hit V to paste that in there. Now, where it says branch rot min X, I'm going to change that to branch rot max X. Okay, so we have that. Okay, good. So I'm going to go ahead and hit Control A to copy it, hit Tab to go on to the next channel, hit V, and mosey this all the way over to max Y, and then hit Tab, go over to V, and move this over to max Z. Hit Enter. Okay, so things are looking kind of wacky here. Aha. So did I do this right? Okay, branch right plus fit max. Okay. Plus, okay. Alright, so we got some positives and some maximums in here. Okay, good. So what we can do here is, I don't like the fact that some of my branches, in fact almost all of them, are pointing down. That's not very fun. So I'm going to click normalize here, just to, it's because it's good behavior here. So I'm going to click up, and I'll say, I don't like the fact that I'm going with negative branches. So I'm going to I'm going to play around with these a little bit. So I'm going to, does this do it? So the z-axis, no, that's not it. So let's try to go with the y. Is this going to have it? Ooh, look at that. So there is some value. So what about my max? I'm going to move this over here. Okay, look at that. Okay, we've got some minimum values. Okay, things are looking groovy. We've got some with it, and we got one negative going on, but that's okay. But they're not all. The majority of them are going in the positive. Okay, so you see here, what we just did was we just dialed in these values depending on what really works best for us and what we want to use. And so I'm going to put my minimum value at 0.1. So as you can see, we want all of our, these are all positive, because we're a happy, more kinder, gentle tree. All right. Okay, we've got that going. So we've got our rotation branches for the tree. All right, now notice that our branch lengths, well, they're basically as long as the parent branch, as the trunk. Okay, what we're going to do is, we're going to get rid of that. And what we're going to do is going to create a fancy expression in order to do this. So I'm going to click into that. Now here's where we got our length, and here's our expression. I'll say Alt-E. Okay, there's the current state of our expression. All right, so what I'm going to do is I'm going to just put a parentheses around the CH here. And I'm going to say, okay, we've got this, all this stuff. This is the old length. But now what we want to do is we want to divide this through by some expression based on the number of iterations that we've got. So we know that we want that the more iterations we have, we want our branches to get shorter. So we're going to divide through here by, I'm going to put an expression here. I'm going to put the expression there in open and close parentheses. And so what we're going to do, I'm going to grab that iteration number and let's do some stuff with it. So CH, open and close parentheses, open and close double quotes, / spine info, spine info iteration. Okay, now I've got the iteration. Now just multiplying it by 2, I'm dividing it by the iteration isn't going to be enough. What I want to do is I want to multiply it by 2 and then add 1 to it. Oops. So times 2 plus 1. Okay, you see, what this is going to do is this is going to produce a number that's even bigger, based on the number of iterations, and we're going to divide that through by truncate. So it should potentially get smaller. This is a good hack. We'll see how this works. So hit apply. Aha. There we can see that the branches are now smaller for this next iteration. Now, we can dork around with this all that we want, but this was just a good approximation, for where it is. We can come back to this and add more variable control to this, because right now they're the same length. And let's put as a mental note, we'd like to come back to here. Maybe expand the length of the branches, longer at the bottom and shorter at the top. Okay, but look at here, gang. We don't have any clumping. The clumping just happens, we've got random distribution of branches all the way through. We don't have any clumping, and so we need some more clumping in here. And look at this, we don't have any control over the start and end of our branch. So what we have to do is something else. And I'm following Jerry's lead, that where I copied this for, is what we're going to do is, we like the scatter sop. The scatter sop is good, it's fun, but we need something a little bit more Rust. So we're going to create our own customized scatter sop. And so that means we're going to get the information coming over here, and then we're going to put all of the information into a group. And you'll see why in a minute. But anyway, what the information does come through, and then we're going to do a scatter-like process onside of the old branches. And then we're going to get rid of all the old branches, and then we're going to copy these new branches to those points, and then it's all going to get merged here together at the end. So we're going to put all the old branches into a group. We're going to put a new scatter in. Then we're going to blow away the old branches. Then we're going to copy new branches to those points, and that should be good to go. Okay, clear as mud, right? Okay. Now, there's a couple more parameters that I'm going to need for this, and so I'm going to return back up to the tree gen level. I'm going to right click on here to go to tree properties, and so I'm going to put in another separator, because this is kind of like just for the randomization of the branches here. So one thing we're going to do is a branch offset, and so I'm going to drag a float. Where's my float? Here we go, float. I'll put this underneath separator. Oops. Okay. And we're going to call this one branch offset. Actually, I'm going to leave that for that, but really what this is called clump offset, because really what these are is they're going to be clumps, and then we're going to be divesting off of the clumps, and so we want a clump offset. So we're going to call this one, we're just going to keep the name, I say branch offset. And for this minimum value, what do we want here? Oh, let's just go with 0.26. Okay, I'm pulling numbers out of my butt, gang. All right, now there's another thing that we want to be able to skip a branch randomly. That means we want our random routine just to suddenly, like if it decides that it doesn't want to draw a branch, well, we're going to give it an opportunity. So we're going to drag another float down here. Go to float branches, and then we're going to call this one branch skip chance. Branch skip chance. All right, and I'm going to call this branch skip chance for the name of my label. And then for my default value, let's go 0.19. So that means that there's a slightly less than 20% chance that we might just skip one of our branches. All right, let's click accept. And there's our new stuff here. So all organized, looking pretty. So let's drop into our tree gen and make accommodations. So we said that we're going to put all of our stuff into a new group, and then we're going to delete the old group. So let's go ahead and branch off of here where it says spine begin, and we're going to say add a group node. Group SOP, and we're going to call the group, well, we're going to call the name, the group create, we're going to call it input. And for the group of the name of our group, we're going to call it input also. Okay, so if we click on display, that's going to show everything in here is in the group. So the old branch here is sitting now in the group, and this is where, if we were to go into here to the information, look under here, and we see that group 1 it has a group called input, and if we click on that and come over here to spreadsheet, if we go over here to primitives, primitives, it says group input, we say primitive 1, it's in group input 1, so that means that's good. So it's got the right information going here. Okay, cool. So we've got our group, and we're going to hook that into scatter. And then what I'm going to do here is, I know this is going to cause chaos, but I'm going to bypass the scatter because we're not going to use that anymore. And then what we're going to do here is we're going to add a blast SOP after the scatter. So I'm going to add a blast SOP. So blast is an elegant Houdini word for delete. Blast. And the group that I want, I'm going to click this little triangular button down here, and no, it doesn't go. Oh, okay, so that's because I don't have the right number of iterations. So I'm going to say the HDA branch level. I'm going to make sure that that equals branch level equal to 1. Is that going to help make things? No entries. Okay, so I'm going to go ahead and type in the word input here. So that's going to input there, but we don't have any information, so it doesn't blast anything away. So I'm going to change that back to 1. Okay, so for the branch levels, I'm going to change that back to 2, so we should be good to go. All right, so we've got that. And we don't have anything here because ultimately, see this little dotted line here? This little dotted line means that there's information passing through, but it doesn't generate anything. And the scatter SOP creates brand new points. It doesn't remove the old points. So here, we still have our geometry here, but we lose it all when we go into the scatter SOP. And so what we have to do is come up with a way of adding more information and get rid of that scatter SOP. So we are going to create a homemade scatter SOP. And we do this by dragging off from the input and dropping an attribute. Well, I don't want an attribute wrangle, I want a primitive wrangle. Yeah, give me a primitive wrangle. You're gonna wrangle me some primitives. All right, and I'm gonna drop this in here and go to the blast. Okay, now you'll see that the blast should have input on here. Okay, blast group input, blast group primitives. Okay. Gather equals 2. All right, cool. So let's go ahead and start dialing this thing in. Now, it's a good thing that we went and created a VEX lesson a couple weeks ago, because we're going to dive into some pretty heavy VEX right here, gang. And this stuff is going to look awesome, and if you wouldn't have taken this VEX course with me a couple weeks ago, you wouldn't understand what's going on, so I'm very glad that we did. But the strategy here is we're going to initialize some values that we need. And then, for every branch that we receive, what we're going to do is we are going to add up and scatter a whole bunch of brand new points along that new branch. And then we're going to make sure that they're within the proper range and to make sure that they're clumping properly. Okay, so that's how things are going to look. And I'm going to name this homemade scatter. Homemade scatter. Okay, so we have the homemade scatter sop right here. Sorry, scatter, we don't need you no more. Okay, so here we go. We're going to type in a lot of stuff. So I'm going to go at this at a medium pace. Follow along the best that you can, and this information will be available for download from the GitHub site after the session. So we're going to start off by creating a local variable called int. Int, and we're going to the master seed. Master seed, and we're going to set that equal to chi, and open close parentheses, and then semicolon. You're going to say, hey, wait, what's this chi business? We've been using the ch operator. That's because everything that we've done beforehand has been technically in H script. And what we're doing now is we're doing it in vex. And right now, vex requires us to create a difference between channels that are integers and channels that are floats. Ch defaults to a float channel. Chi defaults to an integer channel, because I know that master seed is an integer, so that's why we have to put chi in here. So chi, open and close parentheses, open and close double quotes, and go / master seed. Alright, cool. Now, here it is as a local variable. How do we know if this is even printing anything out or if it's even working? Good question. Alright, what we're going to do is we're going to create a print statement. And I'm going to say printf, because this is vex, and vex is a little bit like C for most reasons, without the pointers. So printf, and open and close parentheses. I terminate that with a semicolon. And then what we have to do is a printf statement requires a template for our text string. So open and close double quotes. And so everything we want here, so we want to say master seed, or I'll just say ms, short for master seed, equals, and then we have to explain what kind of variable we want in here. And we know that we're going to be dealing with an integer, and so for printf, there's a specific name for an integer, and it's called %d. That says, okay, %d, that means put an integer here. And then what we're going to do is terminate this with a \n. You say, why \n? Okay, \n is the old C++, or this old C notation for a carriage return. If we don't put a carriage return at the end of our string will just sit around inside of the string buffer until somebody hits line return. Once we hit carriage return, then everything within that carriage buffer is going to get flushed out. So if we're going to go ahead and hit \n, which is going to move everything from the buffer and print it out to the screen. Okay, now the next parameter that we want out of here, outside of the quotes, is the actual value itself. So I say master seed. Okay, so that is going. So what this should happen is master seed, or ms, should get printed out into this value. I'm going to hit Control or Alt return, and that's going to compile. And I didn't get any errors or warnings. So how can we test to see if this works? Excuse me. Hopefully I didn't sneeze in your ear there. Hopefully, it depends on the way I have Houdini set up. Is I'm calling from the command line, and so I'm going to I'm going to look at the command line which I called Houdini from, which is right here. And here we have say, okay, this isn't getting printed at all. So that means we haven't set up our loop correct. Okay, we know this says gather too, so let's take a look here. If this is fetch feedback, or let's see if it's fetch metadata. Alright, fetch metadata 1, metadata 1, okay. So if we hit print this, we get something here. That's good. And did this work? So I'm going to look over here. And it still didn't print. So that means we still haven't gone through, but we are going through here. So we get the input here. We still haven't gotten this. So I really think that this needs to be fetch feedback. Okay, so there's our information. And so here we go into int master seed. So for every primitive that we have, we're going to go printf master seed. hit Alt Return. And then we're going to hit blast. So here we go, print. Okay, so that's, I know, is cooking. So if we have here, all right, everything is fine. So I know that this is cooking here. So let's go over here. Aha, there it is, ms equals 0. So master seed equals 0. So this is not the right formula. So it's a good thing I tested this, because look at this. I did make a mistake. So it says master seed. You know, speaking from a southern accent. Hey, master seed. All right, I want master seed. I'm from the north, damn it. I'm a Yankee. So I hit Alt, master seed, and so am I getting the right values here? Yeah, master seed, ms equals 238. That's what we want. Okay, so now we know that our attribute wrangle is working adequately. Okay, so let's go grab the branch seed next. So int, what we're going to do is int, then call this branch seed equals chi, and then open and close double quotes, parentheses, put in some double quotes, insert / branch seed. All right, I'm going to put that information for branch seed in here just to test it. So I'm always testing. So I'm always doing a unit test because I never trust myself. So BS equals %D, because I know this is also a digital integer value. So I'm going to insert this as branch seed. Branch seed. I hit Alt Return. And does this cook properly? Yeah, it is. MS equals 238, BS equals 84. Okay, now we're cooking. All right, so let's grab the branches and clumps. So int branches, these are the number of branches, equals chi, and open and close double quotes, parentheses, open and close double quotes inside of here. So I'm going to grab the number of children. So / number children. Okay, I'm going to terminate this with a semicolon. And then I'm going to grab the number of clumps. So int clumps equals chi. Okay, open and close double parentheses. Open and close double quotes. / this is called clumps. All right. So now what we have to do is figure out the number of branches per clump. And so what I'm going to do is I'm just going to divide the number of branches I have per clump. So I say int, and we say branches per clump, branches per clump equals branches over clumps. Semicolon. Okay, cool. So I'm going to make sure to test that this is working. So I'm going to look for branches per clumps. And so I'm going to insert after my BS equals %D. Let's say BPC for branches per clump equals, and I'm also going to put a %D here because I know that this is, I'm going to put branches per clump. Branches per clump. Okay, is this working? I'm going to hit Alt Return. I'm going to test this, take a look at my output value. Okay, branches per clump. That equals 4. Okay, cool. So I want to know, do we want to know the number of clumps that we have? Yeah, let's print that out. So let's put in clumps as well. Why not? Clumps equals %D. And then I'm going to put clumps in here. All right, branches per clump. Okay, this is starting to get a little bit long, and it's getting hard to read. So what I'm going to do is I'm going to stick my cursor there right before master seed. I'm going to hit there, and I'm going to do a line return. And so I'm going to hit Alt, Enter, and so this should print out the whole thing. Okay, so there's 5 clumps, branches per clump, there's 4. Okay, so that means that there are roughly 20 branches. Now, it is possible to get something that is not what we expected it before. So, so what we're going to have to do is recalculate our branches. And you'll get to see why, because we're doing a division here. And what happens when we divide an integer by an integer? You get an integer. So that means it rounds down to the nearest integer. So that means that it's very possible that our value for the number of branches that we get after this calculation could change. So let's go ahead and set this. So branches now equals clumps times branches per clump. Branches per clump. Okay, cool. That's just a little reminder that the number of branches that we have here are going to be the number of branches per clump times the number of clumps. Easy enough. Okay. So we've got that information here. And so I think everything is looking good. And so the other information we want here is the range and the range start and the range end. So we're going to get 2 float values. So float space start equals ch. Now notice I use ch because we're dealing with a float and we're not dealing with an integer. So open and close parentheses, semicolon, and then put in here open and close double quotes, dot dot slash child range, and then x. That's the first one. X means the first one. And then I'm going to copy all of this and wipe that in there. I'm going to change the name of my float from start to end. And I'm going to change the x here from x to y and make sure. Okay, so let's see if our start and end are the right values. So right after BPC equals %D, I'm going to say comma, I'm going to say start equals. Now, because this isn't an integer, this is a float, we have to use the name that printf likes for floats, and that, lucky for us, is just %f. %f and end equals %f. Okay, down here, let's go ahead and toss in start and end. All right, Alt Enter. Okay, everything is working, so let's see if it all prints out. Okay, there it is. Start equals 0.2, end equals 0.2. All right, groovy. Now, this is all working as expected. So, this print function is a good way of communicating with our attribute wrangle without having to see some kind of display. And although this information is awesome, I don't need it now because I've tested this to make sure it works. So what I'm going to do is I'm going to comment this out, these 2 lines out, because I don't need them right now. We might come back to them in the future, but we're just going to leave those for right now. All right, there's still a couple more things that we need to initialize, and one thing is that we need to create a vector because we're going to create brand new points here, and the brand new points are stored in as vectors. So I'm going to say vector current point or current pos. All right, and this is going to be just a placeholder, and we're going to go int current point. So every time we create a new point, it's going to get increased. Our number is going to increase, so we're going to keep that around. So we've got our current position, our current point, and now all we have to do is calculate our step size and our current step. Now what those are is this is a way that we're going to get able to iterate through the number of branches, but we're going to be iterating on our clumps instead of our actual branches themselves. And you'll see how this all works in a second here. So we're going to go float step size. So we want to figure out how long our stuff is going from A to B. So this is start size equals end minus start divided by clumps. Okay, end and start are floating values, and this is when you subtract one floating value from another value, it's going to be a float. You divide a float by an integer, you're going to end up with a float. So here's our step size. Okay, this is going to show us how much it iterates on every time, and so our current step is, where this all starts. So I'm going to type in here float, and this is all going to start at the start. So current step equals start. Okay, now I'd like to try to see what these values are just because I'm curious. And so what I'm going to do is I'm going to copy these, hit Control X to delete them, and then I'm going to paste them down here. And then I'm going to uncomment these, and I'm going to make sure that my step size and my current size are being calculated properly. So I'm going to say CS for current size, or SS, step size, equals %F, and then CS equals %F. And we're going to top these out. I'm going to type in the, right after end, comma, we're going to append step size, and then we're going to put in current step. So current step, CS. Okay, let's see if this all works. Control Enter, and I didn't see any errors, so let's take a look at that. And whoa, yeah, look at this. We've run out of information. Okay, now does it work? Oh, it doesn't fit on one side. Okay, but it says, all right, so our step size is 0.14. And then our current size our current step is at 0.2. So this is going to insert 20 branches here, and every time we're going to iterate, it's going to increase this number by 0.2. Well, you're probably acting like the starting place at 0.2, and how does Houdini know what 20% and what 90% is? Okay. Here is something that is a little bit like that you have to understand from working with UV coordinates. Now we have our branch here. It goes here from top to bottom. Now parametrically, this is purely mathematics here, this goes from 0 to 1 because this is the overall, the length in there. So when we say 0.2, that means 20% from the bottom. So like 0.2 is right up here, and then we're going to go all the way up to 0.9 here, which is 90% here. Okay, so this is all working, so I'm going to put these two bad boys inside. I'm going to put those guys inside of comments so that they don't puck out no more. So we've done initializing it. So let's go ahead and then create our loop in order to insert all this stuff. All right, and we're going to do it by creating a for loop. There are lots of for loops in this lesson. So for, and then open and close parentheses. And then we're going to start it off, a for loop in Vex is just like a for loop in C in that it requires 3 parameters. It requires an initializer, a test, and an incrementor. All right, so first we're going to provide our iterator. So we're going to put an int called I. We want an integer called I, semicolon, that's kind of a separator, and then we're going to test it. And we're going to say, is I less than the number of branches? So I is less than branches. Okay, so that means it's going to create no more than 20 branches. And we want this to increment by 1 every time, so it's I plus plus. Okay, there's our for loop. So I'm going to put open and close curly brackets after this to demonstrate. We want everything to kind of like go in between. Okay, there we go, for int I. All right, now what we're going to do is we're going to test if we want to increment our current step. And so we don't want it to increment if this is the first branch or if this is the branch that's sitting on a current clump. Yeah, okay, follow with me for a minute. All right, now this is just something that works. Now you could change this around again, but this is what I'm going to be doing. So I'm going to say if, open and close parentheses, if I does not equal 0, that's what that stands for. I does not equal 0. So that means that if I doesn't equal 0, and we don't type in the word and, we have to do what is ampersand ampersand. That is the vex name for the and Boolean operator. And I percent branches per clump equals 0. Okay, what this means is that if we're not sitting at the bottom and if the number of branches per clump equals 0, so that means that if I is actually one of the branch numbers, then we want to do this operation. So we say current size, or current step, plus equals step size. Okay, so that's going to increment our step size after every iteration. All right, cool. Now, just like we fitted the value between a start and an end for the branch rotation, we're going to fit a new branch somewhere next to our clump, but it's going to be bounded by the variable called branch offset that we created. In fact, while we're at it, let's create a new variable called branch offset, just so that we have it as simple. So float, we'll call this branch offset equals ch, open and close parentheses, open and close double quotes, dot dot slash branch offset. All right, make sure to capitalize that O. All right, terminate that thing with a semicolon. All right, let's deal with this. So we're going to create a new fit. So I'm going to say rand fit. It means I'm going to create a random input to a fit value. So, okay, I'll say float rand fit equals fit 01. Oops, fit 01. Open and close parentheses. Okay, so what we're going to do is it's going to be bound by the branch offset, so it's going to be this minimum and max size. So we're going to say minus branch offset, make sure to capitalize that O, and then comma plus branch offset. I hope I spelled that right. All right. Now those are our delimiters. Now let's put in the actual random statement. So I say rand. All right, open and close parentheses and put a comma after that. All right, inside of a random statement, we want a random value for our branch number, our iteration number, our master seed, and our branch seed. So we want a random iteration, a random number for every branch that we create. So we're going to do this by typing in first at primnum. Okay, remember, primnum is the number of primitive that we're currently working on, and that is a Houdini vex attribute that's given to us by default. And we want to add that to I so that it's a little bit unique. and then we're going to add that to master seed, and then we're going to add that to branch seed. Alright. Ooh, we have to terminate this with a semicolon, and then we should be good to go. Okay, cool. So now, let's figure out how much, where is our spot going to come in inside of the fit range. So I say float u equals clamp current step plus rand fit. So current step plus rand fit. Alright, and a clamp, make sure it's no bigger or no smaller than two values, and we want it to, so no smaller than our start and no larger than our end. Alright, now we have our u value, and u is going to be our position along the branch. So now we have to do is get the actual coordinates for where that is in our branch, based on our u value. And there is a Houdini function that will do that for us, and that's called prim underscore attrib. Okay, prim attrib will give us the attribute information that we're currently looking for. And it requires a handful of inputs. But the first input is where it's coming from. So prim attribute, we're going to get this from the top or our input. So I'll go at capital O for op input 1, okay, comma, and then we want our current value that we want. So current pos. Prim attribute is going to put the return value inside current pos. So we're sending it current pos, and prim attribute is going to insert that value inside of that variable for us. Okay, cool. And then we want the position, so it's open and close P for parentheses, open and close quotes, and then put capital P in there. So capital P stands for position. And then we want the primnum, because this is the current primitive that we're working on. So at primnum, we want the value of u, because this is our position, and then we want the default value of 0.0. Okay, this is going to give us the actual position of our node, of our new point. And then now let's actually go ahead and create the point. So current point equals add point, add point. Add point is a vex function that, you name it, it adds a point. It adds a point, and we're going to add it to our current geo, so it's geo self, oops, open and close parentheses, and we want the current position. We want to add a new point to the current position. Current pos. Okay, there we go, gang. There's our loop. So let's give this a shot and then see what happens. So I'm going to hit Alt-S, and do we get any errors? No. Okay, so let's see what happens here. If we click here, uh-oh, we did get errors. Okay, what's our error here? All right. So, best place to start is at the start. All right, warning. Errors are encountered during vex compile. Okay, uninitialized variable I at line 20. Okay, so line 20. Is this line 20? Okay, so this is good. So, hello. Yeah, this is line 20, so int I, so everything is... Okay, what we could do here, gang, is just to make this clean, just say int I, semicolon, and then just put I. Int I, and then let's say I equals 0. Okay. So we hit Alt-S, or Alt-Y, or Alt-Return. Alright, that got rid of those errors. Okay, and look like Houdini is kind of thinking for us, and I misspelled it wrong again. Instead of master seed plus branch seed, this is master C underscore branch seed. So I'm going to say D, and then change this to plus, and then get rid of that underscore. Towards branch seed, I'm going to hit Alt, Enter, and it's going to rebuild. And so prim attrib is call to unidentified function prim attrib. Do you mean prim attribute? Yes. Alright, hit enter. Okay, reads no matching function. Okay, so our values are no good. So I don't remember what it is. I thought that this was the proper way of doing this, but evidently we are doing this incorrect. So what do? Let's go over here to help, go to contents, and then once the Houdini interface comes up, I'm going to type in prim attrib. Alright, there it is. Reads a primitive value from a geometry outputting a success flag. Okay, here it is. We have to put in our geometry in a string. So the attribute name. So oh wait, here it is. This is a vex function, prim attribute vex function. Show hide. Okay, so attribute name, point number, success, or point attrib, prim attrib. Okay, prim attrib retrieves a primitive attribute from a geometry outputting a success flag. So outputting a success flag. Oh, the type. Okay, so let's see if this works. So we say current pos equals prim attrib, and then get rid of this here. Okay, and then let's look at here. We got our attribute name, which is P, and our primitive is primnum, and our this is not quite what I was looking for. Okay. Alright. Prim attrib. And is there a, I have a hunch that I'm doing, is there prim underscore attrib? Nope. Okay, so something is nutty because I'm dealing with a different function here than what I was used to, and something is not smelling good in the state of Denmark. So what I am going to do is I'm going to look over here into another reference and see if I can find this, because I have this written down for just such an emergency. Hold on a second. Alright gang, it's coming right up here. Just had to kind of shift schedule around a little bit and move things around. coming up with this explanation in a very, very, very short period of time. And actually, considering all that has gone wrong today, things are going actually quite well. Actually, during the initial broadcast of Tech Art Talk Live this morning, right before we went on, the power surge went through the entire house and it knocked out all of our internet. And in fact, it knocked it out so hard is that my wife, the Fall Queen, got her stuff knocked out and she had to cancel her live broadcast, which is, too bad, because her stuff is really, really good. She knows what she's doing. She's taught me everything I know. All right. Okay. I understand. Okay, so what I'm looking for is not prim attrib. So here's Houdini being difficult with us. So it's actually prim underscore attribute. There it is. Prim attribute. This is what we were trying to do. Okay, so it's not current pause. It's prim underscore attribute. Okay, so it's our geometry. This is up input. The value. Now, how do we know we want our return value to go here? Okay, look at here, gang. In the explanation, there's a little ampersand where it says ampersand value. Okay, what does that ampersand actually stand for? Well, in old C terminology, that ampersand means address. Okay, that's a reference to old C, so it's actually, we're sending a pointer. When I said the Vex didn't have any pointers, I guess I kind of lied. Because what we're doing is we are sending the value of current pause into this function, and prim attribute is going to put those values inside current pause. So current pause, and then here's our attribute value. So attribute name, and this is P. Our primitive number, that's prim num. U, well, that's our U value, and 0, that's our current V value. Well, there is no V value because all we're doing is U. It's a one-dimensional, so we only have to deal with one. So thank you very much, Houdini. That should get things working. So current pause, okay. Alt enter. Okay, and look at that. This has now distributed a whole bunch of points along here. Notice that it within the range here. Now it's a random range, so we can't control it here, but we're going to have to require some tweaking. But what we're going to do here is we're going to blast away the old geometry, and so now what we're left is just with these points in here. And over the attribute randomize, we attribute the ends, and then click on the switch, copy the branch. All right, and then we hit spine end, and there we go. Okay, so we're not getting appropriate, we're not getting effective distribution along our clumps. We have all our clumps, but look at here. All of our branches are clumped up together, so our function here isn't working with our clumps properly. So what we have to do is, let's look at our, okay, so rand fit, something isn't right here, and so something is getting 0. So current step, which is going to be according to our current clump actually, plus rand fit, it's going to be 0, it's going to be standard, and so something's happening. So let's test this and actually print out some values and see what we get. So what I'm going to do is, at the end here, I'm going to say printf, open and close parentheses, and then I put a semicolon there, and then open and close double quotes. All right, so what we're going to do here is we want to see what our rand fit value is. Let's say rf equals %f, and then we want to see what our u value is. because that's important. U equals %F. And then we want to see what our current pos is, right? Because we want to know what our position is. So current pos equals %F. And then we want to know what our current point is. Well, not that it really matters so much. So I'm going to say CP equals %D, because that's what it's going to give us. And so let's terminate this with a \n to give us a carriage return. And let's type all these values. So we got ranfit, and we have U, and we have current pos, and we have current point. Okay, one thing I want to do is I want to keep track of which iteration we're going at. So I want things like for the first iteration, the second iteration, and third iteration, blah, 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 blah. All right, so what I'm going to do is I'm going to type in here yeah, sure, why not? Let's give the I value. Yeah, so we go I. Okay, we're just going to say just %D and then arrow. So that's going to be like our current I value. So I'm going to put I value here. So I going there, ranfit. Okay, hit Alt N. Uh-oh, something's wrong. Okay, I said 0.current pos. That's not right. Prim attribute. Ugh. I mucked that up. So it's primnum P primnum U, and this should be 0.0. Alt Enter. Okay, there we go. So let's take a look at our output. Okay, so here is RF equals 0. So here it is. This is the reason why we're not getting anything, because our RF equals 0. So we have to look at that again. But our U equals, okay, here we have our first four values of our clump. They're 0.2, 0.2, 0.3, you know, okay. Everything's going fine. Okay, the 0.9, okay. Everything's looking pretty copacetic. CP display point numbers. Where's that coming from? Okay, here's the problem though. RF equals 0. So let's go ahead and fix this. Okay, RF fit. All right, so let's see, prim. Let's just see if we can get, I'm going to go ahead and comment out this statement because I have no idea where the problem is. But let's just say float ranfit equals, well, let's just go a random number between, so let's just say rand, and let's just say, oh, let's put in the primnum, at primnum plus I. All right, let's just see what happens if we do that. All right, hit Alt, Enter. Okay, something happened. Things changed. What changed? Let's see what's up. Okay. Okay, so RF equals, ooh, look at that. Big values. Sometimes they're 0.4, sometimes they're almost 0, and 0.8, wow. 0, okay, so it is returning values between 0 and 1. Too big information. That's just too much information. So this is just too much information for what we need. Let's go ahead and get that proper information in here. So we've got ranfit, and so let's make sure our master seed and our branch seed are working. So plus master seed plus branch seed. Okay, I'll enter. Okay, we still get nutty values. Okay, we still get our values here. They're all very good, but now we need to bind them or fit them, all these proportions, somewhere in between -0.2 and 0.2. So let's go ahead and fit this. So around this ranfit, I'm going to go fit 0, 1, open and close parentheses. And then I'm going to say minus branch offset. So minus branch offset, and then comma branch offset. And you know what? I just had a thought that maybe my branch offset variable is no good. And so what I just did is I kind of peeky-looed up here to where it says branch offset. I said it's equals ch dot branch offset. So this should be an N. Okay, now let's hit Alt Enter. Okay, there we go. Then we have a good distribution of branches along the end here. Okay, cool. Now let's take a look at this. And so our U values, our RF is somewhere between negative 0.2 and 0.2. Is that right? Yes. Here's our U values. Okay, no bigger than 0.9 and then no smaller than 0.2. Okay, good. All right, so that's great. So I'm going to get rid of my print statement. As much as I love it, it creates just digital noise for the digital bit bucket. All right, hit Alt Enter. All right, everything should change. Now what we can do is dork around here. I'm going to get rid of my parameters. I'm going to go up. And now if I tree gen, P, okay, let's play around with some of these parameters just to see how they work. All right, so here's our branch offset. And so this should control how much we deviate from our clumps. Okay, so there we have all of our clumps, and so here we're going to branch offset off of our clumps. And these are, okay, we got some branch offsets. Okay, that's looking good. And here's our range, so if we can go 0.2, so that means it starts here and goes all the way to 0.9. So if we go here, all right, then we can increase that all the way up to this value here. All right, cool. All right, so everything's good. Oh, we forgot to deal with our branch skip chance. Okay, I'm going to double click, go back in here. Let's deal with our branch skip chance, because this what this provides is a way of skipping some of our branches if we so chose. All right, so what I'm going to do is I'm going to grab this random number. Comes across here, C, and then I'm going to type it in here. So if, and then I'm going to toss that value, rand primnum, I, all of that, and so let's don't add the master seed, so it's going to be different. All right, if the rand value of that is less than skip chance. So is less than ch, open and close parentheses, open and close double quotes, // branch skip chance. All right, if it's less than the branch skip chance, then what we're going to do is we're just going to ignore it. We're not going to create a new branch. So continue. And I hit colon, Alt Enter. Okay, there we go. We skipped some stuff. Okay, look at that. And we're still getting the clumping as we expected. All right. So here's our branch skip chance, and here we can manipulate that. Okay, so we are deleting more. Okay, so that gives it a little bit more of a chance, and that deletes less and less. Okay, so there's no chance there, so it's very small. Okay, so this slider is a little bit awkward, so I might want to change that in the future. So here's this branch offset. Okay, so this moves things a little bit more relative. Okay. All right. Okay, so we have our good branch distribution. So once again, we can change the rotations we want, if we want to get some positive and some negative values in here, here's some positive values and some more positive. Okay, so we got some good values in there. All right, well, this is good other than these branches are lower than the trees. We'll have to create a special case for that. All right, so what if we wanted to create multiple branch levels? So if you had 2 branch levels, what happens if we move this to 3? Oh, check it out, gang. Look at that. We've got lots of little baby branches coming off of here. So look at that. Oh, 3 iterations of our branch, we have like an uber mega tree. All right. Now there's still some noodling around that I'd like to try to deal with. And I'd like to get a little bit more control, like putting some kind of like gradient control in for some of these parameters here. But regretfully, we are just about out of time today. So what I'm going to do is put this information up on the GitHub website. That is ohub_foliage. Go there, you can download this code, and it will be right and ready for you. And next week, what we will do is we will populate this, and we'll put actual bark on this. We're going to put bark on it, yes. Hopefully we're going to do something to this tree length, and it looks like, I don't know, like we're still getting a lot of branches here, and there's a lot of children, and I'd still like these maybe a little smaller, and the number of clumps per level, and the number of children per level, maybe I'd change this down to 10, maybe something a little bit more manageable. Okay, so this is not so wild here, so actually this is starting to look pretty good. Like a crazy-ass TV antenna going wild. Alright, we're going to put bark on this. So we actually had to put geometry on this, we're going to put bark on it, and then we're going to have to put leaves on it. So this is what we're going to try to do next week. So tune in next week to Houdini Secrets Live. We're going to continue this process. We're going to add bark to our procedural tree and maybe toss in some leaves. And then if all goes well, then if we have time, we'll see if we can drop this into UE4 and actually create a digital asset out of it, and so we can actually start designing these trees within the concept of UE4. All right, with that, please go ahead and like the Orlando Houdini users group, and go ahead and please like my TechArt.edu website, TechArt.edu YouTube channel. Yeah, that's it. And if you like that, follow me on @TechArt.edu on Instagram and @RudyPunk on Twitter. We got lots of good stuff for you, lots of good information. All right, thank you very much for your attention and your time today. Stay tuned next week for some even more groovy additions. So until then, have a great week.